this lesson, we're going to look at the material engine in Material Engine? Nope. In this lesson, we're going to look at materials in Unreal Engine, and that includes textures, UV coordinates, and the materials themselves.
Hey, welcome to Real-Time Workflows. I'm MX Bell. I worked on Deadpool and Wolverine, Jurassic World Fallen Kingdom, 1917, Hobbs and Shaw, Wheel of Time, Little Mermaid, No Time to Die, tons more. What you're going to get in the channel are my pro tips and how I use Unreal Engine to make films. So let's get started. Let's make some stuff. See you down the road.
Hey, welcome back to Real-Time Workflows. I'm MX Bell, and I'm going to take you through a beginner's guide to materials in Unreal Engine. Now, we're not going to go fully in depth because that would take fucking hours. There's a lot to learn. This is what you need to know if you're a filmmaker and you've got no CGI background. Let's dive in. I'm going to get a basic plane. And that's called Z fighting. If you ever hear me say Z fighting, that's Z fighting. It means distance from camera, Z. The Z axis from the camera. It's X axis really, but whatever. It means that they're occupying the same depth and then they're fighting because the engine doesn't know which one to display first, because mathematically that grid and the plane are the same distance from the camera. So we'll just lift it up so that it's not. And let's explain first of all what a texture is. Shall we go texture first? Let's go texture first. Texture is basically an image that's painted onto a piece of geometry. Now, I've made a texture that looks like this. It's a simple checkerboard. It's got a dimension of 1024 by 1024. So it's an important thing to note that ideally your textures are going to be square and in a power of 2 magnitude. So that means they should be 8, 16, 32, 64, 128, 256, 512, 1024, all that shit, and square. This was much more important back in the old days. It's still a thing that happens, and just to be on the safe side, I would just keep doing it because it helps with texture processing and stuff inside Unreal Engine. A lot of complicated shit in there that we don't need to worry about as filmmakers, but we should know. Try and keep your textures square. You could go up to like 4K if you want, 4096, but that's just a lot of textures to be thrown at the engine when there's no need. Let's leave it at that. Unreal can also do some processing of textures, but just for a very simple introduction, we'll take this checkerboard. I'm going to drop that into, drag and drop into the engine. Now, it's important to note that that's actually the default appearance of a material, this checker board, this kind of grey and dark grey checkerboard. That's just default. We're creating one that we can kind of use to analyze what's going on. So it's important to note now there's 2 ways to make a material. We can right click on the texture, or we can go create material, and that will create you a checker. So it's the name of the texture underscore matte, or we can make one from scratch. Now we'll just go with which I already did there as a placeholder. This is the kind of preferred naming convention, M for material underscore checker. Let's open this one that it's created and see what it did. So very simple. This is the material editor. I did do a little video on this. It's about 5 minutes long. This is kind of going to replace it. It's a bit more in depth. So this is called a node-based editor. These are nodes that you kind of link in. You drag a node off and you can plug it in somewhere else. That's what node-based is. Nuke is node-based as well. So the Maya has a node editor. It's a good way to learn how to work. So you can see what we've got is a texture sample. And it's got our texture in because that's how we plugged it in, and it's taking the RGB, which is the red, green and blue channels, from the texture and plugging them into base color. Textures, especially PNGs, which is the preferred format, my preferred format, have got 4 channels. RGB to define the color, and A to define the alpha, which is the transparency, which we will get to shortly. This material doesn't have an alpha channel. I know that because I made it. And it's passing RGB through here. You can also pass RGBA into somewhere that would accept 4 channels. Again, we'll get to that. For now, this is just passing RGB through to the base color, which is all we want for now. And if we click on this, we can see some of its information here. So material domain is a surface. That's absolutely fine. Its blend mode is opaque, and its shading model is default lit. Generally speaking, this is the default and this is good. we've got a two-sided option, which we might want to use. Let me show you what that would do. So if we come underneath this cube, this plane, we don't see it, it's not there. If we turn on two-sided and hit apply, and actually apply the material to it, which would help, wouldn't it? Apply the material to it, and then look underneath, and we can now see it. And if we turn off two-sided and hit apply, we do not see it, okay? So that's what two-sided is doing. It is, by default, it's off, and that's to save on rendering time with the engine. Again, not as big a deal with today's computing power, depending on what you're doing, but worth just having off in the meantime. But if you notice any anomalies, it's probably because you need to turn on two-sided. Sometimes it happens. Okay, so let's build one from scratch, which is this one. So we've got a default material. It's halfway between white and black, so it's perfect grey. It's got 0 for metallic, it's got 0.5 for specular and 0.5 for roughness. Let's play with these dials and demonstrate what they do. So metallic is set to 1 will give you can start to see how it's got this kind of metallic-y shine. But let's set the others to 0, we can really isolate what they do. So 0 and, oops, 0. We can see here that now we've got this kind of chrome ball effect, and what that's doing, and you can see this in the lighting video that I made as well, it's reflecting the world that we're in. This demonstration has got a HDR image, which we, again, in the lighting video, those are explained, and that's what it's doing. It's reflecting there. So we can see it twice. We can see what it's doing both times. All right, so if we then set metallic to 0, we get pretty much a boring material. And let's set specular to 1. And now we get a sort of sheen. It's not a chrome ball, it's kind of a sheen, like a plastic sheen on here. But actually our background in this isn't bright enough to reflect it. It's not perfect reflection. We can kind of see it. It's just not as reflective as metallic. And in roughness, if we turn roughness onto 1, we'll lose all reflectivity. Okay, so we used to call that a Lambert shader, basically. The difference between a Lambert and a Phong, those are the two main ones when I learned how to do this. Lambert didn't have a specular component, and Phong did. So we can add our specular component, and by taking roughness off, there's a little bit of repeated usage here. Specular has kind of gone away a little bit. You can kind of get what you want out of metallic and roughness. So metallic will give you that effect, and then obviously you combine them. So metallic and let's say 0.5 on that and 0.5 here will give you kind of this average metallic-y kind of ball. We can take off some of the roughness. So that's metallic at 1 and roughness at 0.2. So it's a metallic, it's got metallic reflectivity, but it's rough. So it's kind of diffusing the reflections. Okay, so that's kind of a bit of an overview as to what these things are doing. Now, how do we control them in a material? Let's plug our texture in and see what it does. So we're going to plug the RGB into base color. What if we were to plug this in to metallic? What this is doing is it's taking our texture, it's looking at our texture, and it's going, right, this is the bottom corner, and it's giving it coordinates in the same way that we talk about coordinates anywhere else. And it's got U and V coordinates, which are the same as X and Y in a normal graph. And what it's saying is we can track along in U and then up in V, and it samples the color, and that's where it goes on the polygon. That's basically what's happening here. And so if we did this and we plugged it into metallic, what it's going to do is going to use the same UVs, but it's going to give us a section that's entirely metallic, which we can see here. Look, that's perfectly reflective because it's white. So that's setting it to 1. White is 1, black is 0. It's setting it to 1, and everything else is set to no metallic, but it's also inheriting the colors as well. We could disconnect that from the colors, and then all we would get is perfectly mirrored white areas, and the black areas aren't. That's the only thing they're getting. The color is set to a uniform color. It's only the metallic that we're controlling using this texture. What if we wanted some transparency in our shader? What if we wanted, in fact, the white bits to be transparent? Well, currently our material is set to opaque blend mode. So what we're going to want to do is change it to be either masked or translucent. We will get to each of those. Translucent allows you to have a fall off of transparency. It can grayscale, will steadily fall off from being completely opaque to being transparent. Masked will be one or the other. So we could go masked for now, and we can then plug our RGB into the opacity mask. And what that will do, you can see here, is made half of it transparent, and the other half is metallic. Now let's get some control here. Let's get some control. What we're going to want to do is add some nodes to this just to demonstrate kind of how to do it and how you might generate materials. Generally speaking, if you've got, we'll demonstrate on a character in a second. A character will have a color, it'll have a normal map. We'll explain normal maps in a second. It might have metallic, specular, roughness maps, and they're all plugged in. But if you're making this material from scratch, you're going to want to know how to kind of control this, and then we'll get to material instances as well. So let's say we don't want to keep coming into the material to set these. We want to be able to input it directly through Sequencer, which we definitely do want to do that. We've got our checkerboard, and we'll plug it into base color. We don't need to plug it into metallic anymore. And we're going to control the metallic and the specular and the roughness and the opacity with inputted values. So rather than me typing them in here in the material editor, we can actually go in via Sequencer and change them. What we're going to want to do is drag off here each of these, and we're going to put scale. I'm going to type in scalar, and that will give us a scalar parameter node. All right, and we'll call this metallic and metallic. And we can set a default value if we want, but there's no need. And we'll do the same thing for these. We can actually duplicate these by Control D, and obviously we'll rename them appropriately. So that'll be spec, and this will be rough, and then we'll plug these into here. And we might also duplicate one and call it opacity. Plug that into there, and now because we dial in a scalar value, we'll change this to be translucent. Now what translucent means is that we can actually have it be somewhat transparent instead of transparent or not. So that means that if we were to we would actually plug this into opacity, obviously, and if we would set this to 0.5, we will see that everything just becomes slightly transparent, as we can see there. If it was to go all the way to 1, it's fully opaque, and if it goes to 0, it's fully transparent. All right. So our default for that wants to be 1, obviously. Okay, so now we've got a material that we can actually set those values externally. The other thing that we can do is we can create a material instance. Now, what's a material instance? A material instance is a way to instancing in CGI. It kind of means a copy that uses the structure of what we've already created, but without creating another one. We call it an instance. It's much less memory intensive. So a material instance, you would want to use, if your material had largely the same properties as this, and you wanted to create, let's say you want to create a different color checker, right? So it's all going to have the same basic properties, or maybe say you want one that's kind of semi-transparent. You would create a material instance of this by right-clicking and go create material instance. And what we do then, the kind of norm is to go MI for material instance. And now if we open this, we get a different dialog. We get this is our material instance editor, and what we can do is anything that we made a parameter in the last one in the material editor, we can change just for this instance of it. We can change it. So we might want to go change the metallic. We might want to change the opacity. Okay. And now we've done that, but we haven't actually changed our original one. And if we went to our original one and we want to be able to actually change the texture on our material instance, we can right click on this and we can convert to parameter. And now we can call it texture node. And if we save that, now our material instance of this will have a texture node, and we can check that and we can replace it with a different texture entirely. So you can actually create, and this is a common practice, you'd create a generic material that's effectively you're only gonna use material instances, because for most materials they're gonna have some combination of textures, metallic, parameter, all that stuff. And actually it's much easier to use one global master material. It tends to be called a master material. And just replace those things in the instance. It's a really efficient way to work. In fact, in my starter pack, one of my things that I need to add to change is that we've actually got materials here for each character, and then there's absolutely no reason that they couldn't be one material and the rest of them be material instances. Okay, so let's look at some practical examples on characters. So let's look at Adam's materials. He's got a material for his body, that's going to be a material for his head. So a normal map, that's a good one. What's a normal? So a normal is the very specific, let's do it on my Batman comic. So here's a Batman comic. The normal on this will be this, okay? It's the perfectly perpendicular angle to the plane surface. Okay, so it always points like this, and you can adjust it, but you tend not to do that. It tends to be done with a texture. So at the same time as we're tracking our texture coordinate, we can arrive at a per pixel and find the normal for that specific part of the texture by looking on the normal map. Whereas if we were looking at a roughness map, we'd be tracking that and seeing what the roughness is at that point. On a texture, we're doing it with the color. On a normal map, we're going to get the angle that the plane should be facing at that particular point. So that means you can get quite fine detail. So you see these kind of things here. So we can see here, we can see the material on this stitching. See, that's not in, and we can even see it on these on the texture of the garment, right? We can see this catching shadow. Now that's not in the geometry. They haven't modeled that stitching. That's in its combination of the normal and what's in the texture. The normal is the thing affecting the lighting. If we unplug the normal, we'll see it will go dark, but we can also see we've lost all that stitching. You can see that you can no longer see it because it's coming in from the normal. It's a function of the normal. So that's what a normal map does. So Adam has a face material, and he's got a hair material as well. So these are all set to opaque. So again, the face is kind of the same. He's got his face material. You can kind of see as well how that's laid out on here. Pretty standard stuff for a face material, and this because this is how the UVs have been arranged, and then the texture goes in on top. This is again an old texture. Look how it's packed into a square. It's 4096. It's 4K, so everything's packed into the square, and then the model knows which part of the texture to go via the UVs to get the material, to get the information that it needs. And you see that they line up as well, right? So our glossiness, if we look at it here, we can see that it's the same. It's exactly the same. It's just telling us that the whiter something is, the more glossy it is. So his lips are more glossy than his skin. And so let's then just look at his hair, because his hair is set to, I've got it set to translucent, right? So if we come and look at him, we can see that his hair is translucent. We can see it because actually the selection line around Unreal Engine, around the object, seems to be bigger than the hair. So if I set this to opaque, we will see now what that does. It removes the opacity and we get this, which looks a little bit crappy, right? But we kind of see the polygons that the hair is made of. Now if we were to set this back to translucent, I think we can agree that it looks much better. And the other mode that you might come across is masked, as I said, and this is either on or off. It's either opaque or not. And so we would plug this. It doesn't use the same opacity channel. It uses a different one. So we'd have to drag the alpha into the opacity mask, and then apply. And what we'll see now is we'll get a rougher edge to the hair because it's either transparent or not. So you see it's got this rough edge, and we're getting quite a lot of we're seeing pixelation because it's just not as smooth. There's nothing feathered about the edges. However, masked translucency is faster. Masked opacity is a faster way for Unreal Engine to render it. It's also good. I'm going to show in another video a good way to kind of animate that as well. So yeah, that's I feel a bit low energy today. I'm sorry if that was a boring video, but I just need to get it done. So we need to have talked about it. And that's an introduction to materials and UVs and textures. So I hope that was useful. If you have any questions, let me know in the comments. We will be putting all these things into practice in a big lesson at the end of in a couple of weeks, basically. These are all just the building blocks that we're doing to build up towards that. So thanks for watching, and I'll see you again.